All right, good day. Today I want to talk about the value of the coefficient of static friction when the object is on an inclined plane, and it is just about to slide, right? You remember when it is just about to slide, the static friction is called, its maximum value. It is called the FFS max, maximum static friction, right? So it's upwards. It's trying to oppose the tendency of the object to go down. And what is moving the object down is the parallel component of the gravity, which is FG parallel, and actually which is mg sine theta, right? So to find the value of mu s, we are going to say this is a very simple procedure. We are going to say when the object is just about to slide, these two forces, the FFS max, the maximum static friction, and FG parallel are balanced. So in other words, they are in equilibrium, right? So all we need to do is we can just make an equation to show that they are equal, which is FFS max is equal to mg sine theta, where theta is the angle of inclination, right? Yeah, so from the formula, FF max is mu s times the normal force. So that is equal to mg sine theta, right? And then remember on the incline, your normal force is equal to Fg perpendicular, the perpendicular component of gravity, which is mg cos theta. So that normal force is mu s is equal to mg cos theta, which is then equal to mg sine theta. Now, if you can see the mg's, they cancel there, they cancel. Let me take a different pen so that you can see more clearly, maybe. So if you look at now this equation that we have now, it is the mg's, they cancel. So in other words, to get mu s, you are going to divide sine theta by cos theta, which we all know that is equivalent to tan theta, right? So in some calculations, you might just need to start here. You have to know that the mu s on the incline is tan theta. Yes, but if they ask you to derive it, then you have to go through this process, right? Okay. Since we have a bit of time, let me just mention something which I feel is very important. It is the fact that we have on the incline regarding friction. Remember, the equations of friction are either this one where you say the frictional force static max is equal to mu s times normal force, or you can have frictional force kinetic is equal to mu k times normal force. So from these equations, it is clear that the friction depends on the normal force, right? And it also depends on, you see, mu s actually is, you might say it stands for the nature of surfaces in contact, or you can just say the nature of the surfaces. Because normally when you do these experiments, you are trying the same object on different surfaces. So you can say the type and nature of surface, right? Because you are trying to keep the surface constant. I mean, you are using the same object. You want to compare the frictional forces, right? And then the other thing that is, because it depends on the normal force, right? And the normal force is mg cos theta, right? You will see that as you increase the angle theta from level, from 0 degrees, you increase it, you will notice that mg cos theta, because cos theta is maximum at 0 degrees, mg cos theta is decreasing, right? That's very important. Mg cos theta decreases because the normal force decreases. So that is very important. But at the same time, remember that your static friction, for instance, static friction, not static friction max, is at each stage as you increase is equal to your As long as the object is not moving, your static friction is equal to mg sine theta. And mg sine theta is increasing from 0 to 90 degrees. So which means before you get to Fs max, you can actually say that as you increase the angle, your static friction is increasing, right? But kinetic friction is a different story because it depends on the normal force. So therefore, your kinetic friction, if they ask you about kinetic friction, as theta increases from 0 to obviously 90 is impossible, it's vertical and the object is just going to slide down. Okay, as it increases from 0 to 80 something or something, what is happening to your kinetic friction is, because it depends on the normal force, your kinetic friction, if you look at kinetic friction, your kinetic friction, you will be decreasing, right? Good. I think that is it. Yeah, right. But obviously at maximum static friction, the maximum static friction there, we have talked about it. This is how you can derive the value of the coefficient of static friction. Right. Is there anything else that I have left out here regarding friction? I think that's basically it. All I can say is, guys, please follow my YouTube videos. If you really want to pass your physics, if you are talking of the ISC, NSC, IEB physics, paper 1, right? Please follow me. You can also follow. I think follow, if you actually, the most ideal is to follow, let me tell you, follow me, follow Kevin Science, follow the Mulungi Singles, follow Mrs. Martins. You won't, because I am going to be loading a lot of content, yeah, non-stop. Okay, please have a good day. Right. I'm looking for my cursor to stop this thing. Oh, it's here. It's very far. Yeah.